Hey everyone, we're going to do section 4.3 today and wrap up this section. We're going to talk about establishing causation, what scope of inference means, and ethics. So it's a short little section that you will not have homework from, but you need to know it for some tests. Okay, so the first thing we're going to talk about is how individuals were chosen and how they were allocated to their groups, which are two different things. So over here, this talks about how people were chosen for the experiment. Did they volunteer to take part in it? Almost all medical study, you have to volunteer to take part in it. So you will volunteer to take part in a COVID vaccine study. You will volunteer to take part in a new type of drug for asthma. You volunteer for it. Then once you volunteer or not, we'll talk about that in a minute, then how you're put into your groups is a separate thing. Okay, this over here talks about were the people randomly assigned to their groups, which is a big thing, right? That's one of your three major things. You have to randomly allocate people to their groups. You can't let them choose. So if people were randomly allocated to their groups, all right, if they were randomly allocated to the groups, then that's one thing. If the people volunteered for the medical study, but then were still randomly allocated, then that is down here. All right, so let's talk about random allocation. So if somebody was randomly allocated to their group, then you can say what we're call cause and effect. Okay, so with the COVID vaccines, I can say, since people were randomly allocated to either get a placebo or the vaccine, I can say that people in this study that are just like them had a 95% rate of not getting the vaccine, not getting the virus. All right. So if I randomly allocate people to their groups, I can say what a cause and effect, basically saying, hey, based on my data, if you do this, it will cause this to happen. So if I administer a drug on asthma, then this is what happened to the people that had the drug. So it's called a cause and effect. It's called causation. All right. But if you have people volunteer and then randomly selected, then you get a different answer. These are two separate things. So this is if I randomly allocate. So once I've picked my people, I've randomly allocated them to their groups. If that's true, then I can do cause and effect. All right, so I'm going to say, if that's true, then I can do something called cause and effect. If I give person a pill, it will cause their cholesterol to lower in that group. All right, now over here is how were the people chosen to be a part of this study? If they volunteered for the study, all right, they weren't randomly selected. They may have volunteered and then randomly allocated to their treatment groups, which is usually what happens. But if you volunteer for the study, okay, if that answer is yes, that if the answer is that they volunteered, that means they were not randomly selected. So if you're not randomly selected from the population, if you volunteered, then you cannot do inference from population. Okay, so what this means is the only way that you can infer out to a population is if you randomly select from the population, so not volunteered. Right, so if you randomly select from the population, then you can infer to the population. Okay, I know this is confusing. So let's say I have a study, an experiment, and I'm going to do random allocation. All right, so then I do my diet thing from the other day. Weight Watchers are like, let's do Nutrisystem today. So they were randomly allocated. Because they were randomly allocated to their groups, I can say cause and effect at the end. So this right here allows me to say cause and effect. Whatever happens at the end here about the weight loss, I can say cause and effect because they were randomly allocated to their groups. Now, this part has to do with how the people got there. All right. So if they were randomly selected from the population, you have been randomly selected to take part in a weight loss study. If you were randomly selected from the population, then you can infer to the whole population. So they're two different things. This and this are two different things. So if you were not, let me clear this back up. Oh, let me clean this back up. So if they were randomly selected, yes, then you can infer out to the population. If they were randomly allocated to their groups, yes, then you can say cause and effect. All right, so challenges. Here's a problem with studies and experiments. It's something called lack of realism. It's really hard to mimic real life. So let's say you were doing drunk driving studies. So you have people drink some alcohol or take something that makes them feel like that they have been drinking alcohol, and you tell them you want to measure their response time while driving. Well, you can't put them in a car when they're drunk and let them drive around. So what we do is we put them in a little simulator and we try to mimic real life. Well, that's a lack of realism. They really know that they're not really going to drive a car, and when they hit somebody in a simulator, they really haven't hit somebody. So we have these problems with lack of realism. So sometimes it limits our ability for causations and conclusions when we have this lack of realism. So that's one thing. Here's things that aren't ethical to do. You can't really do them and mimic real life. Texting while driving. You can't tell somebody to go out and text and driving and see if they have an accident. You can do a correlation, and you could do a simulation in a simulator, but you can't do that. Does going to church regularly help people live longer? You cannot dictate what people do. You can't say, hey, go to church for 20 years and see what happens. And then this is another one, smoking and lung cancer. It has been widely stated for years that smoking causes lung cancer. You cannot tell people to smoke and see if they get lung cancer 20 years down the road. You can't do that. But how do we build a case for this? This is what this next thing is. How do we build a case for like smoking and lung cancer? You like my little skeleton. Smoking. Okay, so here's how you can build a case. Well, first of all, it has to be over a long period of time. The association between these two has to be strong. That means that there has to be, as you smoke longer and longer, your increase of lung cancer goes up. The association is consistent. That means that no matter how many people you do this on, it is consistent answer. Larger values of the explanatory represent larger values of the response. So this is somebody that's been smoking for 40 years and their lung damage. Okay, so that's what that means. And that means if somebody's been smoking for a little bit, their lung damage is not as much. The alleged cause precedes the effect in time, meaning as time goes on, more and more people get lung cancer. And then it's plausible. Does it make sense based off of all of your other studies? Okay, so that's an example of how you can establish causation over a long period of time when you can't really do a true experiment. And then the other thing that we need to talk about is data ethics. You can't force people to drink. You can't force people to drink and drive. You can't force people like women to breastfeed. And people say breastfeeding is better for the baby and all of these other things. Well, how do they know? They can't do a controlled experiment where you have different treatment groups. So you kind of look at that causation and that correlation over time. Well, in order to do any kind of medical study or any study, you need an institutional review board. And their sole purpose is to protecting people and subjects so that they're not abused in experiments, like, how the Nazis did horrible experiments on people. And so this is what we do now. We have these institutional review boards to make sure that those things no longer happen. Well, I mean, it was kind of a different situation, but like so that people aren't abused in any way in an experiment. Individuals, although they could be double blinded or blinded, they still have to give an informed consent. They have to be known that, hey, these are your choices. You may get this drug or you may get this placebo, but we're going to possibly, half of you will happen and half of you, this will happen. So you have to be told what is going to happen. And then all your data, this is called HIPAA rules, right? All your data must be kept confidential. The only thing that is ever released is a number, like your number, like I used 132. And number 132 exhibited these symptoms and had this conclusion. Names are never posted or anything like that. Okay, so that pretty much wraps up the chapter. This page right here is super important in this section about this cause and effect. So let me say this one more time. If you randomly allocate the people to their groups, you can say cause and effect. If people are randomly selected from the population, you can also infer it out to everybody in the population. Okay. For example, the vaccine, and we'll go to the next page, the vaccine for the COVID vaccine. People were randomly allocated to their groups, so we can say cause and effect. So what does that mean? You can say something like, well, people that took part in this vaccine trial had a 95% rate of non-infection from the COVID virus. You can't infer out to everybody, though. You can't infer out to everybody because they volunteered for the subjects, for the study. You volunteered for the study. So because of that, you can't infer out to the population. Alrighty, that is section 4.3.